In Malaysia, a team of elite engineers is racing to build a record-breaking skyscraper.
It's a giant. It is a giant.
This mega-tall tower will soar over 2,000 feet high and cost more than $1 billion.
In physical terms, it's huge.
To construct this colossus, the team must battle sinking foundations,
Then you put more weight on it, it's going to shrink.
torrential rain, stifling heat,
So it's pretty hot, humid and sticky.
and deadly lightning storms.
Looks quite frightening.
This skyscraper ranks in a league of ambitious new engineering wonders that are bigger, faster, taller, and more advanced than anything ever constructed before. This is the inside story of the extraordinary challenge of building. Kuala Lumpur, capital of Malaysia. This vibrant city is a melting pot of cultures. A growing hub for business. And becoming renowned for its giant skyscrapers, such as the famous Petronas Towers. Malaysia's largest investment company, PNB, plans to build a tower that will dwarf skyscrapers across the world. It will be called the Merdeka Tower.
This is a major investment to contribute to the urban development of Kuala Lumpur.
The location they've chosen is one that is central to Malaysia's history.
This project is being constructed on what's arguably the most important heritage site of Malaysia.
60 years ago, at Kuala Lumpur's National Stadium, the country declared its independence.
The Prime Minister raised his hands and the whole stadium raised their hands, uttering the words Merdeka, which means independence.
Architect Carl Fender must design a building that not only commemorates the nation's proud past, but is also a beacon for its bright future.
This is a site that marks a great change in the history of Malaysia and the future of Malaysia.
The Merdeka Tower will rise to become the tallest skyscraper in all of Asia. Its 118 stories will soar over 2,000 feet into the sky. 1 million tons of concrete, interweaved with over 20,000 tons of steel, make up its intricate geometric structure. At the tower's base sits its showpiece entrance, a steel and glass atrium rising 450 feet high. Outside, over 36,000 panes of glass cover its crystalline facade. 5 miles of LED lighting runs along every edge of the tower's diamond-shaped exterior, illuminating it around the clock. Lighting up the skyline, this is a truly revolutionary skyscraper. Project Director Peter Ramstead will be in charge of this mammoth construction. One of his major concerns is the country's tropical climate.
It's going to be a beautiful looking building, but working in Malaysia does have a lot of its own challenges with the weather. Could be sun, heat, thunderstorms that come through.
We do have big lightning strikes here, and when it gets dangerous like that, then obviously we take cover.
The sheer scale of the skyscraper will supersize every challenge Peter and his team face. It will be the tallest building in the world, after Dubai's Burj Khalifa.
In physical terms, it's huge. What goes into the construction of a building such as this, it is mind-boggling.
This is the plan. First, engineers will sink foundation piles 200 feet into the ground, capping them with a 12-foot thick concrete raft to support the tower. Above ground, workers will cast a central core using a huge mechanized mold. They will surround the core with 8 super thick concrete support columns and lock the whole structure together with huge steel arms. 4 giant cranes sit on top of the tower, providing all the materials the crew needs. This includes 36,000 panels of glass, embedded with 250,000 LEDs. Finally, they will bring to life the stunning 42-story steel and glass atrium at the tower's base, a showpiece to mirror the crystalline tower. Work begins in 2014, when diggers start excavating over 100,000 tons of earth. In charge of all on-site operations is construction manager and ex-military man, Gary Salvage.
It's very daunting, right from the planning stages, to make sure that this building can actually be built in the location where it is.
The first major challenge is building a strong enough foundation when the bedrock is inaccessible.
People traditionally think you drill until you hit rock, you do it until you're a couple feet into it, then you stop. Then you know you're in bedrock, right? Yeah, we don't have that here.
Kuala Lumpur is built where 2 rivers converge, and literally means muddy confluence. The ground here is soft sediment, and hard bedrock can be 300 feet or more below the surface.
Most of the time, the soil is not enough to take the load. You need to have the proper engineered solution relative to the soil that you're in. And that gets very complex.
First, trench cutters slice a 3-foot thick channel to create a circle 260 feet across. Workers fill the channel with concrete, creating a huge containing wall, and sink 137 concrete columns, known as piles, 200 feet down into the ground, packed as close together as possible for maximum support. Next, diggers excavate down to reveal the piles, and ironworkers stitch them together with 300 miles of steel rebar. Then cover it with 45,000 tons of concrete. When dry, this ultra-strong foundation should support the vast tower above with ease. Concrete warms as it sets and spoils if it gets too hot. So the team has to do most of this massive pour at night to avoid the daytime heat.
So we're doing everything to keep the temperature as low as possible.
As evening descends on Kuala Lumpur, an army of concrete trucks invades the site.
It's a continuous process. So starting tonight, the car's going to go right the way through the weekend. So I should be pretty tired at the end of it.
The team runs checks on every truckload. they have extreme measures in place for any concrete batch that arrives too warm.
If they do not meet the correct temperature, then we'll inject liquid nitrogen in there to cool the concrete down.
The pour begins.
Good stop and long way to go.
The giant pump arms run around the clock, filling up this huge pit with 3.5 million gallons of concrete.
First 24 hours done. Another 24 more to go.
After an entire weekend of non-stop pouring, rain covers are placed on top for protection, and the mammoth foundations are finally finished. The crew's next challenge is to build 118 stories of super strong concrete up into the sky without a single misstep.
Believe you me, it isn't an easy concrete to chip out if you make a mistake.
In Kuala Lumpur, engineers constructing the 2,000-foot-tall Merdeka skyscraper get ready to cast the tower's huge vertical core and 8 surrounding columns. But as they add each floor level, they'll be confined by a lack of space.
Up top, you don't have much room to work. It would be very, very slow.
The team needs an innovative solution to turbocharge their race to the roof. To cast a single level of a core, workers build a mold from wooden panels and fill it with concrete. Traditionally, they would then remove the panels, build new scaffolding, and lift the molds back up. But for a building this tall, that would take years too long. Instead, steel rails bolted to the core support a giant movable platform that carries the mold sections as it climbs the rails. Workers lock the mold's wooden panels together when pouring concrete and release them once the concrete is set. Then, hydraulics push the platform upwards, effortlessly transporting the molds and equipment up the tower to repeat the process. This clever system means the team can power upwards, adding each new level in as little as 5 days. Inside the huge platform, concrete foreman Perry receives the green light, and the climb begins.
Let's go, Echo.
As the entire platform creeps up, there are just inches to spare. Each worker needs to watch out for any section of platform or formwork that might catch on the newly formed concrete walls. Eventually, the platform stops at the next level. The first climb is a success. Proof their innovative system works.
So we have done our first climbing, so still we need to go 100 more floors. We will do the same way what we see here. We're gonna repeat 100 times.
But as Perry's team adds layer after layer of heavy concrete, this skyscraper will begin to sink.
One of the secrets in building large buildings that people don't really talk about is the settlement of the building. 118-story building is quite heavy. It's going to settle. It naturally will.
Okay?
Every week, at the lowest basement level, a survey team measures the sinking to make sure it matches their predictions.
After structural complete, we are expecting is 90 millimeter settle, the maximum.
The entire floor needs to sink at the same rate, or the tower will start to lean.
The staff is using technology which can measure by the barcode. It's not by eyes because we want to avoid the human error.
The sensor reads the barcode on the staff and automatically detects any change in height. The team works their way around the basement.
Okay, take a reading. Done?
And the growing tower is given the all clear for another week. Meanwhile, the construction team works non-stop and relies on a steady stream of materials, including hundreds of tons of steel each week.
Keeping this building supplied with the steel, with the concrete, the sand, everything, it's a daily task of bringing materials in to keep the building fed.
And the only way to get all these materials to the teams up top is by lifting them, with the help of these mammoth cranes situated on top of the building.
The tower cranes for any kind of high-rise are like the lifeblood of the building. The tower cranes is what gets the material up to the highest parts of the building.
Fed by the busy cranes, the construction team hits their groove, and the skyscraper soars upwards.
Now we're achieving the 5-day cycle. It's very good. One of the things that will be slowing us down now is actually raising the tower cranes fast enough so the core can go up quicker.
This is a problem they must solve, and quickly. If the cranes stay fixed in place, they'll block the tower from rising any further. In Kuala Lumpur, as the central core of the Merdeka Tower climbs higher, its path is blocked by the 4 giant tower cranes.
2 tower cranes on the outside of the building are capable of picking up 65 tons, so, you know, these aren't small plant equipment.
Yet the cranes have a clever design feature that allows them to stay one step above the rising concrete.
Each tower crane can jump itself, so it only needs itself to move itself up the building.
The skyscraper's cranes are attached to its concrete core with 2 giant steel brackets. But as crews build the core higher and higher, the cranes have to move up. Otherwise, they'll impede progress. First, engineers install a 3rd bracket higher up the tower that supports a pair of narrow metal ladders. With these in place, engineers move the crane's metal feet onto this super strong ladder. A hydraulic press raises the crane up. When it reaches the rung above, a 2nd set of feet catch onto the ladder. The hydraulic piston resets and pushes off again. By climbing up each 2-foot-high rung at a time, the cranes stay ahead of the crews below.
Habiskan semua kerja dalam pukul 5.
Today's crane jump is led by San Karan Kanan. He's head of safety for all equipment on site, including the giant tower cranes.
Safety slogan ready?
The team begins by detaching the bolts that keep this 220-ton monster locked in place.
Sekarang kita akan mula jacking.
San Karan sends his men into the tower crane support column. With a 600-foot drop below them, the team and the huge crane begin to climb. Suspended on nothing but 2 narrow strips of steel.
So these 2 ladders is supporting the entire structure to climb. We trust on the engineers who built this crane. So
the hydraulics powering the crane lift are under huge pressure and must be controlled precisely. The crane's steel feet catch each rung. One thunderous bang after another.
Each time it's hook, we're gonna hear a massive sound. Bang, bang, and bang. So it's considered it's normal. So don't get afraid that why suddenly we have a sound.
It takes 3 hours for the climbing crane to reach the safety of the next bracket. The workers lock the crane back into position, ready to return to action the next day.
We are done.
But the higher the tower cranes climb into the sky, the closer they get to Malaysia's potentially deadly thunderstorms. When a storm hits, the cranes stop and the workers seek cover. With 4 notable exceptions. The crane operators.
They stay in the cabs. Safest place to be in the cab because it's all isolated. But it's quite frightening. Most crane operators keep their own change of underwear up the top there as well, you know.
A lightning strike can still knock out the crane's electrical system. So the worse the storm gets, the bigger the impact on Gary's schedule and budget.
They're very expensive. They need to be in operation all the time. Obviously time is money and they've got to be working, they've got to be earning their money.
In tropical Malaysia, a thunderous storm halts construction of the record-breaking 2,000-foot tall Merdeka Tower. Once the storm finally clears, San Karan and his team check for damage.
As the storm and rain stop, our technician will climb all the cranes to ensure there's no any failure so the crane can work safely.
The tower cranes creak back into action. The team building the tallest tower in Asia is almost a third of the way to the top. But as they approach the 40th floor, they face a new challenge. They must tie the central core to the 8 giant concrete support columns that surround it.
These type of buildings, very tall buildings, these mega high-rises, naturally want to twist, want to torque, want to lean.
The core and the mega columns have only the thin floor levels to connect them, and could start to move independently. To secure them, engineers insert giant pieces of steel into the concrete columns at 3 key levels up the tower. They connect them to the core with enormous diagonal arms called outriggers. These tie the columns and the core together, allowing them to support each other and move as one. For extra stability, engineers encircle the same levels with huge steel trusses that grip the tower like a series of belts, making it strong enough to extend high into the clouds. The outriggers are so large, the team has to crane them up in separate pieces and weld them together after they've been installed. The strength provided by the 3 levels of outriggers will be crucial to the entire building.
The boys here need to keep this clear.
So Gary oversees this first level personally.
We look for the most experienced guys to do this. This isn't an easy job.
The welding crew uses powerful induction heaters to warm the steel outriggers to 175 degrees.
If the steel was cold, you wouldn't get the good conductivity between the weld and the plate that you're welding.
This is a massive undertaking. Each outrigger level has over 40 huge joints, and it takes a team of welders 100 hours to complete each joint.
You look at the joint itself, it's, you know, fillet weld, it's big. In fact, it's just like the VMI hands there, you know. It's over 300 passes all the way around. It's a big chunk of weld.
Any moisture could fatally weaken the weld. So the team shields their handiwork from the rain and works in shifts to complete the join as fast as possible. After 4 days, this final weld is finished and ready for inspection.
This weld has to be a solid piece of metal just like this. You don't want no cracks in the armour. You know, it's a beautiful building and we want to keep it that way.
The metal is so thick, the crew needs to use ultrasound to search for any defects hidden below the surface. The join checks out, and Gary signs off on the first outrigger level.
All the welds have all passed their tests, we're happy with that. We only want the best here, obviously.
The first third of the tower holds strong, and the crew just needs to repeat the process twice more to reach full height. As the Merdeka Tower grows higher, Gary's workforce grows ever bigger.
This is one of the biggest job sites in KL at the moment. We have over 3,000 workers on here.
But not everyone works above ground. In the 4 huge basement levels, engineers are installing the mechanical, electrical, and plumbing systems, known as MEP.
MEP can touch the life for every person.
Abbas Alizi is in charge of all the systems needed to make the finished building habitable.
The temperature of the aircon inside the building, the lighting. Without gas, for example, you cannot do the cooking for the people.
Abbas leads a small team of engineers responsible for enough wiring and plumbing to serve an entire city district.
We have to go to site every day to make sure that everything goes as they plan and as it is in the specification.
Each day, Abbas and his deputy Johnny prowl the basement levels, checking up on all the installation teams.
Boss, hey, how many welders you have? Where is the welder? I think we talked to your boss about the distance here.
Their greatest challenge is to install the enormous air conditioning system. And in this tropical climate, that's no easy task.
Sometimes the things don't go too smoothly.
In tropical Kuala Lumpur, where a team is building the enormous Merdeka Tower, the temperature is a humid 80+ degrees all year round. So keeping the building cool will be a huge job.
You don't want to see AC units hanging off the outside of the building. You know, this is a smart building. This is a modern building, shall we say.
This gargantuan network of pipes is part of a monster cooling system designed to combat Malaysia's tropical temperatures. The operation to cool the tower begins deep underground. First, diggers excavate a giant water tank, big enough to fill 14 Olympic swimming pools. Beneath the building, giant chiller units will cool the water down to 40 degrees. 9 enormous 100-kilowatt motors spin pumps that force the cold water up the tower, where it cools air on each floor. Higher up the tower, extra pumps keep the cold water moving all the way to the top. This vast network will circulate 10,000 gallons of water every minute to keep the tower cool despite the tropical heat. For Abbas's installation crew, squeezing the cooling system's machinery into an increasingly crowded basement is no simple task.
Not only chilled water pipe, there's a cable tray, there is a firefighting pipe. So all maybe cross at the same area. So before they do any installation, they have to coordinate it well.
Today, the crew is installing the last of the 9 giant motors that sit on top of each water pump. These drive the entire cooling system.
It's difficult because it's quite big. As you can see, the space is quite small.
They lift the 5,500-pound motor and gently rotate it to the correct angle. The motor is a precise piece of engineering, and the crew can't afford to get any bumps or scrapes on it as they begin the installation. But they soon run into trouble. The forklift can't lift the motor high enough to put it into place. The crew needs to install the motor today to stay on schedule. They have no option but to remove an overhead cable tray to make more headroom for the forklift.
It has a surprising element. Okay, that's why we must work quite careful and slowly.
With the extra space, the crew takes a second shot. The forklift creeps forward with millimeters to spare. The motor finally touches down, and the giant cooling system is complete.
Sometimes the things don't go too smoothly. Okay? Sometimes we have some problem.
Of course, there is a lot of surprises during the construction. Cannot be 100%, but we try to make it 99%, 99.9.
But the tower's cooling system is no help to the construction crews currently working in Malaysia's tropical climate.
We have 2 seasons here. It's hot or it's raining. That's it. There ain't nothing else.
Rest breaks are crucial in the oppressive heat. But even when the sun sets, another danger remains: disease-carrying mosquitoes. Pest control teams need to fumigate the site every night. If a single case of dengue fever is reported, the Ministry of Health would quarantine the entire site for 2 weeks.
If our site closed down for 2 weeks, it's a very bad news.
Well, you can imagine how that would affect the schedule of this project, and especially it being a multi-billion-dollar job, then, you know, there's big money involved.
Daily spraying with insecticide keeps workers safe and the site running smoothly. Gary needs the tower's schedule to stay on track. That's because he's gearing up for the biggest single operation of the entire construction. Lifting the 60-ton keystone for the enormous atrium.
This is the biggest lift of the project.
The the steel installation team will need all the help they can get. Because on this build, you can never be too careful. The Merdeka skyscraper is rising fast. Crews are installing the giant window panels and testing the LED lighting that will be one of the tower's signature features. But one major showpiece of the tower's design is still to be built. The atrium, an enormous structure at the building's entrance.
The volume of the atrium is to do with the scale of the building. We're standing underneath one of the tallest buildings in the world. It's appropriate to have an atrium, an entry experience, a start to the building, which is equally wondrous as the tower itself.
This will be a 450-foot-high hollow shell of steel and glass.
What is that? It's a huge space. As you walk into the entrance of the building, you can look all the way up 44 floors.
Assembling this giant steel frame in mid-air is a precarious job. And the team has reached a crucial stage. They're installing the central piece of the atrium's framework, called the node. It's the heaviest single segment of steel on the entire project. This will be the biggest lift of the build, and it's got Gary worried.
What we are going to lift now is 52 tons.
Quite heavy.
Quite heavy, yes.
This 120,000-pound block of precisely engineered steel is the most important part of the tower's vast atrium. The team must lift the node at exactly the right angle so it fits onto its supports perfectly. To do that, they use two cranes, one to hold the bottom end clear of the ground, and the other larger crane to rotate it. Once it is at the right angle, the main crane lifts it up the tower, and the workers on the atrium's colossal steel beams carefully guide the node into position. They must get the placement of this behemoth perfect, because it alone will hold the entire 42-story atrium together. The two cranes quickly rotate the node to the correct angle. Workers detach the smaller crane, and the bigger crane begins the main lift. But bad weather is on the horizon.
Rain is coming from north side.
North side?
Yeah.
Is it heavy rain or like a drizzling something?
And before long, a storm is right on top of them.
Wow.
The risk of a lightning strike is too great. The crew is forced to halt the operation.
We're lowering it back down, and we'll start again later.
And the alarm goes off to evacuate the site. The next morning, the crew raises the node back up as quickly as possible. But they can't rush the final placement. because there's no room for error.
You have to get it in the right position. You have to maybe tilt it to the left, tilt it to the right. If it's out by 1 degree, it's not going to meet up with that mega columns.
Manipulating 120,000 pounds of steel is hard work. But finally, the node is in position.
Fantastic. Good job. Well done.
Thank you, sir.
All right, good.
Now the rest of the giant atrium can rise up safely.
Now that's in, we can just carry on and fly straight up the side of the building now with the rest of the steel.
This crystalline-shaped skyscraper climbs to the clouds. And Asia's tallest tower becomes a new jewel in the crown for Malaysia's skyscraper city.
Is iconic because of what it represents. To come together and bring progress not only for our current generation but for future generations.
Part of the success of all major buildings is the fact that they work on people's imaginations. That sort of symbolism is what makes these sort of buildings legends within a city.